Hello everyone. I am Shruti Pandey from the Chemical Engineering Department of IIT Kanpur, and I welcome you to the first lecture of the chapter Haloalkanes and Haloarenes in Chemistry of class 12th. So, you all must already have studied about the hydrocarbons in the previous chapters. So, but nevertheless, I'll try to give an introduction of these hydrocarbons. So the hydrocarbons are the compounds that they are the organic compounds that contain the hydrogen and the carbon atoms only. They do not contain any other any other element like sulfur, nitrogen, oxygen, or the halogens. So they are generally they are taught that the hydrocarbons they are of two types according on the basis of their structures. So one type of the hydrocarbon that is more common is the aliphatic hydrocarbons, and the other one is the cyclic hydrocarbons. So the aliphatic hydrocarbons, they are generally the open chain hydrocarbons. That is the chain that is formed by the carbon atoms that is open. And the several examples of the aliphatic hydrocarbons, they include the alkanes, alkenes, and the alkynes, and the different isomers. So talking about the examples, alkanes. Alkanes are the saturated hydrocarbons. That is, they do not have any double bonds, and all the carbon atoms they are attached to the single. So every carbon they must satisfy the 4 bonds, right? So it is the every carbon is attached to the 4 different species. Obviously, the species they can be same also, but the bonds are 4 and they are single. 4 single bonds are there. So it is a saturated hydrocarbon. And the other one we come to alkenes. Alkenes are the unsaturated hydrocarbons because they contain they may contain one or more than one double bonds. And alkynes are the unsaturated hydrocarbons that contain one or more than one triple bonds. So the alkanes you must have heard about the ethane, propane, butane. So propane is CH3, CH2, CH3. Because propane is because it has 3 carbon atoms, and in the same compound, like if we have one double bond, so it becomes propene. Because this double bond is present, so it is propene. It is an alkene. So this was all about aliphatic hydrocarbons, and then we come to the cyclic hydrocarbons. So basically, cyclic can also be divided into 2 types, that is the aromatic and the non-aromatic. Aromatic and the non-aromatic compounds. We will talk about the requirements of the aromaticity later on in this lecture itself. But first, let's talk about the cyclic hydrocarbons as a whole. So cyclic hydrocarbons are the hydrocarbons, the chain in the aliphatic when it is closed up. Like this chain, when it is closed up and it forms a cyclic compound. So this is a cyclic hydrocarbon. It is cyclopropane because so these are the carbon atoms over here. There are 3 carbon atoms and the 2 bonds are here and 2 other hydrogen atoms are there for every carbon atom. So this is a cyclic hydrocarbon, but it is non-aromatic. Now, when we'll talk about the aromaticity, we'll discuss about this in detail. But yes, cyclic hydrocarbons, the chain is completely this loop is closed. Okay, so that simply means that not all the cyclic hydrocarbons they are aromatic. So some will be aromatic and some will be non-aromatic. So then we'll go on to talk about the requirements of the aromaticity. How can we define aromaticity and what all compounds they can said to be aromatic. So the first and important requirement is that the compound must be cyclic. That means कि aromaticity is not found. This property is not found in the aliphatic hydrocarbons or the aliphatic compounds, that is the open chain compounds or their isomers and all. So it is not present there. Then the second requirement is that it must be in conjugation all the way around the ring. That means, in simple words, if we say that every atom in the ring must be able to participate in the pi bonding, or we should have alternate double bonds in that compound, in that cyclic compound. For example, conjugation around the ring. For example, in this benzene ring, we can see that every carbon atom in this benzene ring, it is participating in this double bond, right? There are 6 carbon atoms, and you can see every carbon atom is a part of a double bond. There is a pi bonding there, and there are alternate single and double bonds. So this helps in the conjugation. That means conjugation, if we talk in terms of electrons, it simply means that the electrons they are able to transfer from one carbon atom to the other carbon atom easily. So they can simply travel all around the ring. So that is conjugation. And other example, this is the benzene ring, and when you add OH, like this is the phenol group, OH hydroxyl group, so it becomes phenol. Right. Now, this is conjugation. Then the third requirement for the aromaticity is that the molecule, it must be a flat molecule. Okay. And then we coming to the fourth, that it must follow the Huckel's rule. That is, Huckel's rule says that the number of pi electrons, they must be 4n plus 2, where n is an integer. So let me write down the Huckel rule. That the number of pi electrons which are there in that compound, वो कितने होने चाहिए? They must be 4n plus 2. Okay, so n is an integer, means when we'll put n equals to 0, so we'll get 2. When we'll put n is equals to 1, we'll get 6. And putting on the different n values, we will get 2, 6, 10, 14, 18. That means that compound must have, and so on. So the series goes on. If the compounds, they are larger and they have the different aromatic rings, so it depends, the series will go on. And if that compound is having all of these 4 properties, then only that compound is said to be aromatic. Otherwise, it will not fall in this category. Okay, so we can list down some examples over here. Like this is a carbon, and this is a double bond over here. Okay. So if you will count the number of pi electrons, is that the number of electrons which are taking part in the pi bonding, that is the double bond over here. So there are 2 electrons which are taking part. So here are the number of pi electrons, here is 2. So 1 pi bond means 2 electrons, right? Then talking about the another example, this is the cyclic compound with the 4 carbon atoms, and here we have double bonds, 2 double bonds. And so if 1 pi bond means 2 electrons, 2 pi electrons taking part, so here are 2 bonds, that means the number of electrons is 4. Okay, but this 4, I mean from the it is a cyclic compound, it is a flat molecule, and it has the alternate double and single bonds. That means the second criteria is also being satisfied over here. That is, the conjugation is there. So alternate double and single bonds. But again, this requirement number 4 is not satisfied, because we see that the number of electrons, the pi electrons, should be 2, 6, 10, 14, 18, and 4 is not there. So this will not be regarded as the aromatic compound. Okay. Similarly, when we talk about benzene, which is a very, you will find benzene everywhere. In the later chapters also, we will see, in the later topics also, we will see that most of the aromatic compounds, they contain benzene. Okay. So if we'll count the number of pi electrons, we have 3 bonds. So 3 into 2, 6 electrons. 6 pi electrons are taking part. So that means it follows the Huckel rule. Then the first requirement is also satisfied. It is cyclic. Then we have the conjugation around the ring, that is the alternate single and double bonds, and it is a flat molecule. This flat molecule assumption is basically if the other three are followed, there are 90% chances that the molecule is flat. So like if we want to say that whether a molecule is aromatic or not, we generally look to the other three examples because we don't know कि whether actual में structure flat है कि नहीं है. ठीक है. So all the three assumptions are satisfied over here. So this is also a aromatic compound. And similarly, when we'll go for 8-legged octagon, and we'll put up the single and double bonds alternate. Here also the number of pi electrons is 4 into 2, that is 8. And it is not following the Huckel rule, so it is not considered as an aromatic compound. So it is not aromatic. So this was a general introduction about the hydrocarbons and their classification. And this is about aromaticity. Next we'll go to the halogens. So halogens, they are the elements which constitute the group number 17, that is the second last column of the periodic table, group number 17 of the periodic table. And so when you look up the periodic table, you will see that there are 6 halogens, that there are 6 elements in this second last column. And so they are named as fluorine, which is denoted by F, chlorine, which is denoted by Cl, bromine, which is denoted by Br, and iodine, which is denoted by simple I. Next we have astatine, denoted by As, and then we have tennessine, which is denoted by Ts. So these are the 6 halogens that are present in the periodic table. But we generally, like in the organic chemistry, we are only concerned with the first 4. Like these only we are concerned with the fluorine, bromine, chlorine and iodine, and not with the other 2, because astatine, first of all, it is a radioactive element. So it cannot be used, like it is a radioactive, so it is a harmful element. So we are not considerate about this element. And then talking about tennessine, the chemical nature of tennessine is still not known to the researchers. So I mean the work is still being carried on, and we do not exactly know about its nature. And it's a very high molecular weight element. So we do not talk about this also. So in this chapter, we are only concerned about the halogens, and we will denote halogens with the symbol X. Okay. This X, wherever like we'll write down the structure of any organic compound and we'll use X, that means that we are talking about the halogen over that place. And that X will either be equal to F or Cl or Br or I. Okay. Now, what are haloalkanes and haloarenes? Okay. So what we learned is that about the about the hydrocarbons, right? So when we replace the hydrogen atom in an aliphatic hydrocarbon, we get the haloalkane. I mean, let me write it here. When we replace, like if it is a aliphatic hydrocarbon, that is the open chain compounds, and when we replace H, so we get the haloalkanes. These haloalkanes are also called alkyl halide. We'll go through this when we'll see about the nomenclature of these compounds. And when we come to the aromatic hydrocarbon, so when we have aromatic hydrocarbon, and when we replace hydrogen in the aromatic hydrocarbon, we will get haloarenes. or the aryl halide. Okay. So this is how the haloalkanes and haloarenes are formed. Now, so why are we interested in these compounds? Okay, whenever we study something new, there is a reason behind that. Okay, so the reason that we are interested and so much like still new ways they are being discovered for the formation of these haloalkanes and haloarenes, because they find wide applications in the industry and even in day-to-day life. So in the industries, you must have like talking about the simple applications, you must have studied about the solvents. So it also contains chlorine, so it is used for treating malaria. And then halothane is also a compound that is used as an anesthetic during surgery. Okay, so these were some of the classification. These were some of the applications, that is the medical applications of these haloalkanes and haloarene valley compounds. So this is the reason why we are interested. So why are we interested in these compounds? Like, what are the applications of these compounds that we are studying these, and we are also, I mean, the research is also being carried on, finding out new ways for the formation of these compounds. So the very first application is that they are used as solvents for the relatively non-polar compounds for dissolving them. Okay, and then they are also used as for the synthesis of the other class of organic compounds. Like when we'll go on to the chemical properties of these compounds, we'll see कि हम इन्हीं haloalkane और haloarenes को use करके as a starting material, as a reactant, हम बाकी और सारे organic compounds बना सकते हैं, important organic compounds. Then these compounds are very much in use in the medical field also. Like for example, we have chloramphenicol. It is an antibiotic which has chlorine, as the name suggests. And this antibiotic is used for the treatment of typhoid fever. Then another example is that we have chloroquine. It is also used for the treatment of malaria. And we have halothane, that is used as anesthetic during the surgery. That is for जो surgeries में anesthesia use करते हैं ना, उस body part को सुन करने के लिए, that is anesthesia. So halothane is a compound that is used over there in that medicine. Okay. So these were some of the like very few applications of these compounds. So this was the basic introduction about these compounds, and next in this chapter we will discuss the classification on the different bases. Then we'll talk about the nomenclature. Like there are two types of nomenclature, that is the common names and the IUPAC names. So we'll talk about them. Then we'll talk about the different methods of preparation of these compounds. And then in the last, we'll go on to the physical and the chemical properties of these compounds. They can be used for the synthesis of other compounds as well. So we'll also go on to that topic. So let's now go on to the classification of these compounds. ठीक है, so classification भी अलग अलग basis पे ही किया गया है. So the first basis that we are going to talk about is on the basis of number of halogen atoms. Okay, this we can classify into monohaloalkanes, the dihaloalkanes, and the polyhaloalkanes. Okay, so coming to this is like when talking about the monohaloalkanes, that when the compound contains only one halogen atom, then we'll say it as monohaloalkane. When it contains two halogen atoms per molecule, we will call it as dihaloalkane. And when it contains more than two halogen atoms per molecule, एक ही molecule में दो से ज़्यादा halogen atoms है, मतलब एक ही molecule में सपोज करो 3 या फिर 4 या उससे ज़्यादा halogen के atoms है, क्लोरीन हो गया, फ्लोरीन हो गया, सेम भी हो सकते हैं, like they can be the same halogens and they can be the different also, like one is fluorine, the other one is bromine, the other one is iodine. So that will also be polyhaloalkane. Okay. So mono, di, and polyhaloalkane. And similarly for the haloarenes also, if there are aromatic rings present, that will be the haloarenes. और वहाँ पे हमने हाइड्रोजन की जगह पे अलग अलग हाइड्रोजन एटम्स को सब्स्टिट्यूट किया हुआ है. Compounds containing sp3 carbon and halogen bond. So this X, as I told you earlier, no, this X means the halogen atom that we are talking about, the halogen. So this CX bond, ठीक है, यहाँ पे जो कार्बन है that is sp3 hybridized. So you must be aware of this hybridization, no, that when we talk about sp3, sp2 and sp hybridized atoms. So here also, in short, like if we say in simple terms, sp3 carbon means that the carbon is attached to the 4 species and it has 4 single bonds only. So then in simple terms we can say that the carbon is sp3 hybridized. Fine. So here also when we talk about the classification, first we will get is the alkyl halide or the haloalkanes. Alkyl halide, and we denote it as Rx. R represents the alkyl group and X represents the halogen. ठीक है, so that this is a homologous series. And जैसे हमने alkanes और alkenes में आपने पढ़ा होगा कि alkanes को हम लोग रिप्रेजेंट करते हैं CnH2n+2 से, वैसे ही यहाँ पे हम लोग इसको रिप्रेजेंट करेंगे CnH2n+1 से. वाई? क्योंकि और एक X यहाँ पे, क्योंकि वो जो 2n+2 में मतलब नंबर ऑफ हाइड्रोजन एटम्स थे ना, उसका एक हाइड्रोजन हटा के हमने एक हैलोजन लगा दिया है, तो वो 2n+1 हाइड्रोजन बचा है. ठीक है, so this is the homologous series. Now these alkyl halides, they are further classified as primary, secondary or tertiary according to the nature of carbon to which halogen is attached. मतलब जो हैलोजन जिस कार्बन से अटैच्ड है वो कार्बन कौन से टाइप का है. अगर वो कार्बन है, वो प्राइमरी कार्बन है, तो हम लोग उसको प्राइमरी अल्काइल हैलाइड बोलेंगे. अगर वो सेकेंडरी कार्बन है तो उसे हम लोग सेकेंडरी अल्काइल हैलाइड बोलेंगे. नाउ अब प्राइमरी और सेकेंडरी कार्बन भी आपने पहले पढ़ा होगा, बट आई एम गिविंग यू अ इंट्रोडक्शन अबाउट दिस कि वो होते क्या हैं. तो प्राइमरी कार्बन इज व्हेन यू हैव ओनली वन अदर कार्बन अटैच्ड टू इट. फॉर एग्जाम्पल, ऐसे नहीं समझ आएगा. लेट मी ड्रॉ अ मॉलिक्यूल. तो सपोज ये हमारा कार्बन है एंड इट इज अटैच्ड टू वन हाइड्रोजन यहाँ पे, एंड इट इज अटैच्ड टू वन अनदर हाइड्रोजन यहाँ पे. एंड क्योंकि ये हैलो एल्केन है तो यहाँ पे एक हाइड्रोजन एटम रहेगा एंड यहाँ पे एक एल्काइल ग्रुप है R प्राइम. सो हियर R प्राइम इज द एल्काइल ग्रुप. दैट मीन्स कि ये जो C है ना, ये किसी एक और कार्बन एटम से अटैच्ड है, क्योंकि ये C सिर्फ एक ही कार्बन से अटैच्ड है और बाकी सारे जो स्पीशीज हैं वो कुछ और हैं. मतलब यहाँ पे इन दिस केस इट्स हाइड्रोजन एंड हैलोजन. when a carbon is attached to only one carbon atom, then it is said to be the primary carbon. And so यहाँ पे जो alkyl halide है, that will be called as the primary alkyl halide. Now talking about the secondary. ठीक है, this is C, this is hydrogen, this is a group which is R prime, and this is a group which is R double prime. ठीक है, और यहाँ पे halogen है. तो यहाँ पे क्या है कि जो कार्बन है ना, वो सिर्फ एक ही हाइड्रोजन से अटैच्ड है और बाकी जो दो हैं वो हमारे एल्काइल ग्रुप से, मतलब R प्राइम और R डबल प्राइम. तो इसका मतलब ये जो कार्बन है, इट इज अटैच्ड टू द टू अदर कार्बन एटम्स. ठीक है, दैट मीन्स ये जो कार्बन है वो 2 डिग्री कार्बन है या फिर सेकेंडरी कार्बन है. तो इसको हम लोग 1 डिग्री या फिर प्राइमरी बोलते हैं, इसको 2 डिग्री बोलते हैं या फिर सेकेंडरी. सिमिलरली तो ये वाला जो एल्काइल हैलाइड होगा ना, इसे हम लोग बोलेंगे सेकेंडरी एल्काइल हैलाइड. नाउ टॉकिंग अबाउट द टर्शरी. तो सिंपल है, उसमें भी क्या होगा कि जो कार्बन है व्हेन इट इज अटैच्ड टू द अदर 3 कार्बन एटम्स, तो दैट मीन्स देयर मस्ट बी 3 अल्काइल ग्रुप्स। वो अलग अलग होंगे या सिमिलर भी हो सकते हैं। R prime, R double prime and R triple prime, these are the different alkyl groups and this is the halogen of course। ठीक है, तो इसे हम बिकॉज कार्बन है वो 3 कार्बन से अटैच्ड है, सो दिस इज द टर्शरी कार्बन। और ये जो ओवरऑल कंपाउंड है इसे बोलेंगे टर्शरी अल्काइल हैलाइड, दैट इज द 3 डिग्री अल्काइल हैलाइड। क्योंकि जो हैलोजन है वो कार्बन से अटैच्ड है एंड दैट कार्बन इज 3 डिग्री, इस वजह से इसको 3 डिग्री बोलेंगे। फाइन, सो दिस इज टर्शरी, right? Now in this category only we have the second classification alkyl halide के बाद, that is allyl halide। तो मतलब ये sp3 कार्बन वाले क्लासिफिकेशन में ही है, so this is को हम लोग बोलते हैं allylic halide। ठीक है, तो these are the compounds जिसमें जो halogen atom is bonded to an sp3 hybridized carbon atom adjacent to the carbon-carbon double bond। Maybe or maybe not you must have studied like in the previous chapters also। तो allylic वाला जो ग्रुप होता है ना, allylic group is something like this। जो ग्रुप होता है allylic, that is there is a double bond and there is a carbon। ठीक है, ये वाला जो ग्रुप होता है ना इसे allylic ग्रुप बोलते हैं। Why? क्योंकि ये जो कार्बन है ना ये खुद डबल बॉन्ड का पार्ट नहीं है, इसके बगल वाला, इसके जो एडजेसेंट कार्बन है दैट इज अ पार्ट ऑफ द डबल बॉन्ड। तो इस वाला ग्रुप को एलाइलिक ग्रुप बोलते हैं। एंड व्हेन हम लोग एलाइलिक हैलाइड के बारे में बात करेंगे तो क्या होगा, लेट मी गिव यू एन एग्जांपल इन दिस ओनली। ये डबल बॉन्ड CH2X, मतलब देखो इसका स्ट्रक्चर कैसा है कि जो कार्बन है दिस कार्बन इज नॉट अ पार्ट ऑफ द डबल बॉन्ड। मतलब ये जो हैलोजन है ना जिस कार्बन से अटैच्ड है, तो इसको अगर ओपन करके लिखे तो क्या होगा कि ये C है, ये एक H लगा हुआ है, ये एक H लगा हुआ है और ये एक X लगा हुआ है। दिस इज द हैलोजन एंड दिस इज अटैच्ड टू सम अदर कार्बन एंड ये जो डबल बॉन्ड है ना ये इन दोनों कार्बन के बीच में है। ठीक है, तो मतलब ये जो हैलोजन जिस कार्बन से अटैच्ड है उसके पास दैट इज नॉट अ पार्ट ऑफ द डबल बॉन्ड। ठीक है, तो ये ध्यान रखना है कि एलाइलिक ग्रुप में ऐसा होता है। एलाइलिक हैलाइड हो गया। ठीक है, तो अगर हम इसी को उसमें एरोमेटिक में देखेंगे तो क्या एग्जाम्पल क्या हो जाएगा कि दिस इज द हैलोजन एंड लेट मी ड्रॉ द रिंग। ठीक है, तो यहाँ पे भी हम क्या देख रहे हैं कि ये जो हैलोजन इज अटैच्ड टू दिस कार्बन, राइट, दिस, एंड ये कार्बन जो है ना दैट इज नॉट अ पार्ट ऑफ द डबल बॉन्ड। इसके बगल वाला कार्बन जो है ना दैट इज अ पार्ट ऑफ अ डबल बॉन्ड, सो ये भी एलाइलिक हैलाइड ही होगा। ठीक है, now coming to the third classification, third variant of this category, that is sp3 is benzylic halide। okay, so when the halogen atom is bonded to an sp3 hybridized carbon atom which is attached to an aromatic ring। ठीक है, अभी क्या था ऊपर वाले एग्जाम्पल में, इस वाले एग्जाम्पल में हमने देखा था कि ये जो रिंग है ये बेंजीन रिंग नहीं है। वाई? बिकॉज बेंजीन रिंग में 3 डबल बॉन्ड होते हैं ऑल्टरनेट, सो ये बेंजीन रिंग नहीं है, इट इज सिंपली अ साइक्लिक कंपाउंड। लेकिन बेंजाइलिक हैलाइड में क्या होगा कि वी आर ओनली टॉकिंग अबाउट द क्योंकि बेंजाइलिक है तो इस वजह से वी बी गोइंग टू टॉक अबाउट द बेंजीन रिंग ओनली। तो लाइक CH2X एंड दिस कार्बन, ठीक है, मतलब हैलोजन जिस कार्बन से अटैच्ड है वो कार्बन ही पूरा बेंजीन रिंग से अटैच्ड है। ठीक है, तो इसमें यह ध्यान रखना है कि ये जो कार्बन है विच इज अटैच्ड टू द हैलोजन दैट इज नॉट अ पार्ट ऑफ द बेंजीन रिंग। ठीक है, ये बात ध्यान रखनी है क्योंकि एक अलग ग्रुप भी होता है, वी विल टॉक अबाउट दिस जस्ट अभी इन अ फ्यू मिनट्स, कि उसे हम कुछ और बोलते हैं जिसमें कि जो कार्बन होता है दैट इज अ पार्ट ऑफ द बेंजीन रिंग। हियर कार्बन इज नॉट अ पार्ट ऑफ द बेंजीन रिंग। ठीक है, ये अलग से है, जो C है ये बेंजीन रिंग के बाहर लाई कर रहा है जिसे हैलोजन एटम अटैच्ड है। सो दिस इज बेंजाइलिक हैलाइड। ठीक है, और कॉम्प्लेक्स एग्जाम्पल के बारे में बात करें सो वी कैन ड्रॉ दिस। ठीक है, ये हमारा बेंजीन रिंग है। बेंजीन रिंग को हम ऐसे भी डिनोट करते हैं, इफ यू मस्ट बी अवेयर, कि 3 डबल बॉन्ड लगाने के बजाय अगर हम ऐसा भी बना रहे हैं बीच में सर्कल, सो दैट इज ऑल्सो डिपिक्शन ऑफ द बेंजीन रिंग ओनली, एंड देयर इज नथिंग रॉन्ग विद दिस अनलेस एंड अनटिल 3 बॉन्ड्स हैं। ठीक है, तो लाइक इफ दिस इज अ कार्बन एंड दिस कार्बन इज ऑल्सो अटैच्ड टू दिस इज एक्स, ये थोड़ा कॉम्प्लेक्स स्ट्रक्चर हो जाएगा। दिस इज सम अल्काइल ग्रुप R प्राइम and this is another alkyl group that is R double prime. So this is a little complex structure, लेकिन बात वही है कि जो halogen है that is attached to a carbon and that carbon is attached to a whole benzyl ring. ठीक है, now we come to the another basis. Like अभी तक हमने क्या देखा था कि on the basis of the number of halogen atom, और the second one was on the basis of the sp3 like sp3 hybridization वाले कार्बन में अटैच होता है तो। ठीक है, now we are going to talk about the compounds which are containing the sp2 hybridized carbon X bond. तो यहाँ पे जो कार्बन का हाइब्रिडाइजेशन होगा वो sp2 होगा, अभी तक sp3 था, राइट? सॉरी, दिस इज अ सिंगल बॉन्ड। ठीक है, सो इसमें वी ओनली हैव 2 कैटेगरीज। So the first one is vinylic halide. When the halogen atom is bonded to the sp2 hybridized carbon atom of a CC double bond, मतलब जो विनाइलिक हैलाइड होता है वो जो ग्रुप होता है, मैं आपको पहले वो बता देती हूँ कि ये CC डबल बॉन्ड है एंड यहाँ पे कुछ अटैच्ड है। ठीक है, ये जो है ये कुछ अटैच्ड है, तो इसको जो बोलते हैं दैट इज अ विनाइलिक ग्रुप। और अगर हम हेलाइड्स के बारे में बात करें, विनाइलिक हेलाइड, तो देन द सिंपलेस्ट एग्जांपल वुड बी दिस। ठीक है, और वी आर गोइंग इनटू द साइक्लिक कंपाउंड्स एंड दिस इज अ डबल बॉन्ड यहाँ पे X। ठीक है, तो इसमें क्या है कि जो हमारा हैलोजन है जिस कार्बन से लगा हुआ है, लाइक जिस कार्बन से अटैच्ड है, दैट कार्बन इज इटसेल्फ इज अ पार्ट ऑफ द डबल बॉन्ड। ठीक है, तो ये कार्बन ही में ही डबल बॉन्ड है। और सिमिलरली यहाँ पे देखेंगे ये जिस कार्बन से लगा हुआ है दैट इज ऑल्सो अ पार्ट ऑफ डबल बॉन्ड। नाउ अगेन पीपल गेट कंफ्यूज्ड बिटवीन द विनाइलिक हैलाइड एंड द एलाइलिक हैलाइड। एलाइलिक हैलाइड में हमने क्या किया था कि लेट मी राइट डाउन द एग्जांपल। सो ये C था and it was attached to this C, ये हमारा एलाइलिक ग्रुप था, राइट? तो इसमें क्या था, जो हैलोजन जिस कार्बन एटम से अटैच्ड है दैट इज नॉट अ पार्ट ऑफ द डबल बॉन्ड, उसके बगल वाला कार्बन इज अ पार्ट ऑफ द डबल बॉन्ड। ठीक है, तो ये बिल्कुल ही डिफरेंट स्ट्रक्चर्स हैं, बस इसलिए बता रही हूँ ताकि यू डोंट गेट कंफ्यूज्ड आगे जाके। ठीक है, तो ये हो गया विनाइलिक। और सेकेंड कैटेगरी जो इसकी आती है दैट इज द एराइल हैलाइड, जिसमें कि क्योंकि एराइल आ रहा है इसका मतलब है कि एरोमेटिक कंपाउंड होगा, बेंजीन रिंग भी इन्वॉल्व होगी। ठीक है, तो हैलोजन इज डायरेक्टली बॉन्डेड टू द sp2 हाइब्रिडाइज्ड कार्बन एटम ऑफ एन एरोमेटिक रिंग। ठीक है, जरूरी नहीं है बेंजीन रिंग हो, इट कैन बी एनी एरोमेटिक रिंग। ठीक है, तो फॉर एग्जाम्पल हमारा बेंजीन रिंग है, तो यहाँ पे जो हैलोजन इज अटैच्ड टू द कार्बन एटम एंड दैट कार्बन एटम इज इटसेल्फ अ पार्ट ऑफ द बेंजीन रिंग। ठीक है, सो दीज आर द एराइल हैलाइड्स। सो व्हेन वी वर टॉकिंग अबाउट द बेंजाइलिक हैलाइड, बेंजाइलिक में क्या था, इधर पे लिख बनाते हूँ, बना देती हूँ मैं। तो बेंजाइलिक क्या थे, इट वाज दिस थिंग लाइक CH2 and X. Like the carbon atom which is attached to the halogen, that is not a part of the ring here. लेकिन यहाँ पे this carbon atom is a part of a ring. ठीक है. So this is the difference between the aryl halides and the benzylic halide. So you don't have to get confused. Very simple. Now so this was all about the classification. So what we did was that we considered three bases. The first one was on the basis of the number of halogen atoms. Second one was the sp3 hybridized carbon, and the third one is the sp2 hybridized carbon halogen bond. Okay. So this was all about the classification. Next we'll move on to the nomenclature. So nomenclature basically it consists of two parts, like common names and the IUPAC name. So IUPAC, it has several rules, and like there are so many rules are there that you have to follow while writing the IUPAC convention. I'm not going into the detail of the IUPAC because I assume that you all must have studied it in the previous chapters itself. So, but yes, I'll be just helping you out. So, okay. So we have common names and we have the IUPAC names. So with respect to common names, if we talk about, so general जो pattern होता है naming का is that alkyl group followed by the name of the halide. Followed by name of halide. अभी it will be clear like when we'll do the examples and all, बहुत clear हो जाएगा. और IUPAC के बारे में बात करें तो the general pattern is halo substituted. Hydrocarbons. ठीक है. So what we'll do is we'll directly go to the example so that it will be easy for you all to understand कि difference क्या है और कौन सा ज़्यादा सही रहता है. So the first example that we'll take up the compound is CH3, CH2, CH2, Br. Right? Okay, so the common name for this compound is, so I'll first write down the common name and then below it I'll create a table then. So this is the common name and here I will write down the IUPAC one. Okay. So common name of this compound is N and propyl bromide. क्यों? Because the alkyl group followed by the name of the halide. तो common name के क्या जो pattern होता है that is हम लोग पहले जो भी हमारा alkyl group होता है that means जो halogen जिस भी group से attached है पहले वो group लिखते हैं और उसके बाद में halide का नाम लिखते हैं, halogen का नाम लिखते हैं. So this is N propyl bromide क्योंकि ये जो तीन कार्बन वाला जो this group which contains three carbon atoms, this CH3, CH2, CH2, this is the propyl group. ठीक है. So because it is not a kind of isomer, it is a simple chain, like a single chain. So it is N-propyl. So we will call it as N-propyl bromide. And talking about the IUPAC, IUPAC simply says that this is written as 1-bromo propane, simply. IUPAC says कि पहले हैलोजन लिखूं, हैलोजन का नाम, सो हियर इट इज ब्रोमीन, सो इट इज 1 ब्रोमो प्रोपेन, और बाद में हाइड्रोकार्बन का नाम लिखना है उल्टा, ठीक है. सो द ऑर्डर ऑफ राइटिंग द alkyl group and the halogen, that is different for both these conventions, ठीक है. So generally we follow the IUPAC convention only because I think it's more easy to understand. I'll tell you later because there is some kind of confusion in the common name side. So I'll let you know about this. First we'll do more examples. So here the bromine is so here you must be aware, no, that while writing the IUPAC name we need to number the carbon atoms, right? So bromine यहाँ पे और कोई ग्रुप तो अटैच्ड है नहीं, सिर्फ ब्रोमीन है, तो हम लोग यहीं से नंबरिंग शुरू करेंगे एंड विल राइट एज 1 2 एंड 3, ठीक है. तो क्योंकि ब्रोमीन जो है वो फर्स्ट कार्बन एटम नंबर 1 से अटैच्ड है, सो वी आर राइटिंग इट हियर एज 1 ब्रोमो प्रोपेन, ठीक है. नाउ कमिंग टू दी this is H3C, CH, CH3 and यहाँ पे Cl लगा हुआ है, क्लोरीन, right? So common name says isopropyl chloride. ठीक है. So see in the first and the second example the number of carbon atoms is same. ऊपर भी 3 था, नीचे भी 3 है, but the difference is कि here the bromine was attached to the first carbon atom and here chlorine is attached to the middle carbon atom, the second one, right? So this group, जब पहले कार्बन एटम से कोई एलिमेंट अटैच्ड होता है या फिर कोई और ग्रुप अटैच्ड होता है, so that comes under N propyl, like that comes under N category, ठीक है, normal. और when anything is attached to the middle carbon atom, ठीक है, सो दैट कम्स अंडर द आइसो कैटेगरी. तो इसी वजह से हम यहाँ पे आइसोप्रोपाइल लिख रहे हैं. आइसो मीन्स कि जो भी चीज अटैच हो रही है वो सेकेंड कार्बन एटम पे अटैच होगी, मिडिल वाले पे, ठीक है. तो इसी वजह से वी कॉल इट हियर एज आइसोप्रोपाइल एंड क्लोराइड, ठीक है. एंड इन टर्म्स ऑफ IUPAC इट इज 2 chloropropane because it is attached to the second carbon atom. So again you will number it in the same way like we did in the first one. It is 2 chloropropane. ठीक है. Now the third example is तो इस वाले कंपाउंड का जो कॉमन नेम होगा दैट इज आइसोब्यूटाइल क्लोराइड, क्योंकि ये वाला जो पूरा ग्रुप है, ये जो पूरा क्लोरीन जिससे भी अटैच्ड है, ये जो पूरा एल्काइल ग्रुप है दैट इज सेड टू बी द आइसोब्यूटाइल ग्रुप. व्हाई? बिकॉज सी नंबर ऑफ कार्बन एटम्स इज 1 2 3 and 4, सो इट विल बी ब्यूटेन, ठीक है. इट विल बी ब्यूटाइल एंड इट इज आइसोब्यूटाइल बिकॉज इट इज एन आइसोमर, राइट. सो क्योंकि यहाँ पे एक सीख है, जो एक और लास्ट वाला कार्बन एटम है दैट इज अटैच्ड टू द मिडिल कार्बन हियर, ठीक है. अच्छा, नॉर्मल जो एन ब्यूटाइल होता है दिस इज आइसोब्यूटाइल, राइट, व्हेन इट इज इन दिस फॉर्म. एन ब्यूटाइल में क्या होता है कि ये जो दिस चेन होती है ये पूरी ओपन होती है ऐसे, लाइक इन अ सिंगल लाइन. तो अगर क्लोरीन यहाँ पे अटैच्ड होता तो वो नॉर्मल ब्यूटाइल पे चला जाता, लाइक इट वुड बी कॉल्ड एज नॉर्मल एन ब्यूटाइल क्लोराइड, ठीक है. बिकॉज इट इज अटैच्ड because this thing is an isomer of butyl group, so it is a isobutyl chloride. That's a common name. Okay. And talking about the IUPAC, it's 1 chloro 2 methyl propane. 1 chloro. अभी I'll tell you कि इसका like why it is written in this way. कि एक में ब्यूटाइल लिख रहे हैं और दूसरे में प्रोपेन लिख रहे हैं, सो व्हाई दिस कंफ्यूजन इज देयर, दिस डिफरेंस. सो IUPAC कन्वेंशन एज आई टोल्ड यू नो कि इट कंसीडर्स लाइक इट विल टेक द लॉन्गेस्ट चेन एज इट्स मेन चेन, ठीक है. और बाकी जितनी भी चीजें उससे उसकी मेन चेन से अटैच्ड होंगी और फिर हम उसे साइड चेन बोलते हैं, एंड फिर हम उसे साइड मतलब दूसरी तरीके की नंबरिंग करते हैं, 1-2-3- ऐसे करके, ठीक है, IUPAC कन्वेंशन में. So the if you see in this example, the longest chain कौन सी होगी? 1 2 3 वाली, ठीक है, this 3 longest chain. तो because यहाँ पे दो चीजें अटैच्ड हैं एंड हमें नंबरिंग इस तरीके से करनी पड़ेगी कि वी गेट द like we get the lowest numbers in our IUPAC name, ठीक है. तो so the best way would be 1 2 and 3 because this is the longest chain. तो अब we'll see कि जो क्लोरीन है that is attached to the carbon number 1 and ये जो हमारा मिथाइल ग्रुप है this is CH3, this is methyl group is attached to the carbon number 2. इसी वजह से we have named it in this way. It is 1 chloro 2 methyl propane क्योंकि हमारा जो मेन चेन होगा ना that will be the main compound, that will be the जो हाइड्रोकार्बन हम यहाँ एंड में लिखेंगे प्रोपेन that will come from the longest chain, that is the main chain. और बाकी जितनी चीजें होंगी that would be considered as the side chains, ठीक है. This is the benzene ring and here the halogen is attached. This is bromine, ठीक है. Now here for the single halogen, like for the monohalogen compounds which are attached, like monohalogens when they are attached to the benzene ring, the IUPAC and the common name they both are similar, ठीक है. क्योंकि because only one halogen atom is there और कोई group भी attached नहीं है, तो this is simple one and so it is known as bromobenzene in both the conventions. Common name में भी हम यही लिखते हैं and IUPAC also says bromobenzene. Now this was monosubstituted halogen, ठीक है. Then we'll go to the disubstituted compounds like benzene ring and it has two halogens, one here and one here, ठीक है. So in common names like see when we have multiple substitutions in a benzene ring, sorry I forgot to write this. When there are multiple substitutions in a benzene ring, you must have heard of like when we say ortho, meta and para, ठीक है. तो ortho is, let me write it down here. ऑर्थो मतलब when कार्बन नंबर 1 और कार्बन नंबर 2 पे अटैच्ड हो, वो जो मतलब डबल सब्स्टिट्यूशन होगा जब when it is attached to 1 and 2 then it's ortho. Meta is when it is attached to 1 and 3 and para says when it is attached to 1 and 4, ठीक है. So this is the convention for the common name convention. So here like we'll take the initial letters only like O for ortho, M for meta and P for para, ठीक है. तो because हम लोग यहाँ पे देख रहे हैं कि when we'll name it तो 1 2 and 3, तो 1 और 3 पे मतलब एक कार्बन छोड़ के दो कार्बन पे लगा हुआ है, that means it will come in the meta category. So the common name क्या हो जाएगा? It will be M डाइब्रोमो, क्योंकि दो ब्रोमीन है तो डाइब्रोमो और बेंजीन, राइट. एंड कमिंग टू द IUPAC सेज आप नेमिंग करो एंड उसके बाद जो भी उस मेन हाइड्रोकार्बन में जितनी भी चीजें लगी हुई हैं देन नेम इट एज द साइड चेन, ठीक है. तो यहाँ से हम शुरुआत करेंगे 1 2 3 4 5 and 6. दो ब्रोमीन है 1 पे और 3 पे, so we will simply write it as 1, 3 डाइब्रोमो बेंजीन, ठीक है. तो यही डिफरेंस है IUPAC और कॉमन नेम में कि इन कॉमन नेम यू विल हैव टू रिमेम्बर कि ऑर्थो, मेटा और पैरा कौन सा कैटेगरी फुलफिल कर रहा है एंड देन वी विल राइट इट डाउन इन द नेम. IUPAC में this is one advantage is that we don't need to remember too much things because you just have to select the main chain, and if it's here it is simple because it is simply a benzene ring. So यहाँ पे आप लोग you just have to do the correct numbering and then write down everything that is attached to the correct places. So here it is bromine at 1 and 3, so you can simply write it in terms of numbers. Okay, and if we attach, like when there are three bromine atoms. Okay, so common name में we simply call it as SIM. When alternate जगह पे लगे होता है, like this one carbon leave करके alternate carbon atoms पे bromine attached है, so this is SIM tribromobenzene. ठीक है, and in IUPAC again we can simply say that it is attached to the 1, 3 and 5 positions. So 1, 3, 5 tribromobenzene. Okay, so these were the several examples of the nomenclature, and we had studied about both the conventions, that is the common name and the IUPAC. So this was all for today, and tomorrow we'll do some more examples of these nomenclature, and then we'll move on to the synthesis of the haloalkanes and haloarenes. Like there are different methods of manufacturing these, so we'll go on to those methods of preparation. So thank you. This is all for today.